Hi everyone, welcome back to a new video. Today is day 9 of our top interview 150 question, and the question that we have today is jump game. It is a medium level question, and the problem says that we have been given an array nums, okay, and means originally or initially we are standing on the 0th index, and after that what we need to do, we need to reach the last index. If we are able to reach the last index, we need to return true, otherwise we have to return false. Now how do we decide how to move forward, right? So every element that we have been given on each index is the amount of steps that we can jump, and it is the maximum amount of jumps. Okay, so if we are on the 0th index, so I can move from 2 means 0th index to first index, or I can also move to second index, right? Because the maximum steps that I can take is 2 steps, right? Now if I come to the first index, I see the value is 3. Now I can move to one index. After that I can again move to second index. Means after the first index I can take one index, then two indexes, and then I can reach the last index, right? And what will happen, let's say if I went to this index, okay, so I reach here. Now I can take one step from here, right? So I will come to this index, and from here I can take one more step, so I will reach 4, right? So now we have a basic idea of what we have to do, right? So now what will happen means, what we are basically doing, if we are on the 0th index, okay, so the number of steps is 2. I can all take one step also, I can take two steps also, and the outcome for both will be kind of different, right? So in this case what we are doing, we are trying to explore all the conditions that are possible. And in the cases when we try to explore all conditions, the first thing that comes to our mind is recursion. And once recursion comes into picture, then we try to optimize it, and then dynamic programming comes into picture. Okay, now let's see how to solve this problem using recursion. Okay, so we have been told that we need to reach the last index, right? So we know that if our index reaches the length, means if this is n, okay, so we reach n minus 1, then what will happen, we can return true, right? And for each index also we need to check how many possibilities are there. So let's say if I am on 0th index, I can go till less than n, right? Now for when I am on 2, I can go to 3 also, I can go to 1 also, right? I can go on the first index also, I can go on the second index also. And in order to try both possibility, what I will have to do, I will call this function again, right? So this is what I will be doing here. I will be calling, let's say my function name is jump. So I will be calling jump again. And what I will send here, I will be sending means how many steps can I jump, right? So I can send this index. After this I can means if I am on first index, I can send this value, right? So what I will do, I will send I plus 1. Now if I am iterating from I is equals to 0 to n, okay, now if I am on the 0th index, so how many steps I can move, I can move from 0 to 2 index, that is possible, right? So if I am starting from I plus 1, then I can go till I plus nums of I, right? So now we see that our iteration that is possible is from I plus 1 to I plus nums of I, right? Now the other condition is, let's say I am trying from I is equals to 0 to n. Instead of that, what I can do, I can simply change it into let's say this value that is getting passed from here is index. Okay, so I can start from index only, so that every time I am passing I, that is value greater than 1, so I can iterate in the entire array, right? Let's say I am on 0th index, then I can start from I plus 1. uh, let's say on we have the 0th index, right? On that position we have 2 as the value. So from where can we start? Like we will be starting from I, means this whatever this value is, we will be starting with plus 1 value only, and we can go till where this sum value is getting added, right? Our index value is 0 and num set I is 2, so we can go till second index, right? So what we can give the condition, let's say we are using j to iterate, so we are starting from I plus 1 and we are going till less than equals to nums of I plus I, right? Now we have this as condition. Now when we are on the like, okay, we are on the 0th index, and now we what we need, we will be moving to this index because our second iteration will be starting from I plus 1. For this also I have to check all the conditions, right? For that what we will do, we will be like we will be again going inside, we have to check conditions for that also. So for that what we will do, we will use recursion, right? So we will let's say our function name is jump, and we have to pass index also, right? So I will be using I only for passing the index, and we will have nums here. So I will be calling jump and I will be passing I, that is j here, right? We will be passing j and nums. Now let's say we have 2 here, we went to the 3, then we went to if we are, I mean, stepping 3 steps, then we will reach the fourth like last index, right? So this 3 will be returning true to us, right? In case when we have reached the end of the recursion, right, and we are getting true, then we can simply return true from here, right? And when it will become true, when we have reached the last index. So in order to make this condition as true, we will have a base condition, right? So what we will give, that if I is equals to length of nums minus 1, then what will happen, we will return true. Now let's say we have a condition, we have 2 1 0 3. Okay, now we will be starting from this index, we can go to this index or we can go to this index, right? And if we are starting from this index, we can go to this index only. Now what is happening, when we are coming at the second index, we are seeing 0 is there, right? And if there are 0 zeros, means you cannot move anymore forward. So in such cases what will happen, you will have to just return false, right? Because you will not be able to reach the last of the array. So we have one more condition here, that if you see at any index of nums that we have 0 here, then what we will do, we will return false. Now this is our two conditions, right, inside jump function, and we have I here and nums here. Now we have jump in like we have I and nums. Now this index, we are on the we will take the previous array only. So we had 2 3 1 1 4, right? 3 1 1 4. Now we have started iteration from this. After 0th index, I can move to 1 index or 2 index. So whatever iteration we are starting from I plus 1 only. Now if we are passing 0 from this I, so our j, the inner loop will go start from I plus 1, right? So our j loop will start from I plus 1 and will go till less than equals to, what is the value? If we have 2 here, then it is I plus nums of I, right? Means we are going till second index, right? If we have 3 here, means we are on the first index and we can go till 1 2 3 4, means we can go till go to fourth index, right? We can go to the fourth index, which is 0 1 2 3 4. We can reach the last index, right? So therefore we need to add our I with the nums of I in order to get the maximum index that we can reach. So let's say we can max reach is equals to I plus nums at that index. So max, we will go till less than max reach. Okay, now what we have to do, if we have already, like we are here, okay, we have 3, and what is happening, we like we checked for 3 and we are reaching to the last index using 3 here, right? So if our, like this j value is less than n, right? This when we are at 2, so when we are calling I plus 1, that means j is means j is at first index, and now with this 3 I can reach the last value, right? So this j is less than n and I am getting my value also, so I can give a condition here, right? If j is less than n, and I have one more condition, that the whenever I am calling the function again, I need true from there, right? So if jump returns true, which is I will be passing I plus 1 here and nums here, this, it will not be I, it will be j. I need to pass index from here, right? It will not be j also, I need to pass, yeah, it will be j only, because I plus 1 either, or it will be j. So I will be going with j because I need to iterate on that, right? So we will be passing j here, and now what will happen? If this value is becoming true, then I can return true here. Why am I giving this condition, right? Let's say now I have reached the value where j is equals to n. Okay. Now if this is like j has reached n, that means I have not got my value, right? I have not got a value such that I can say that I can reach the means the last index, right? So when the j value is less than n, right, then only this condition can become true, that we can reach the last index. And if this condition becomes false before only, then we will not have to go into like recursion, right? That's why we are using the condition j is less than n, and if it will become false, simply we can return false, right? Otherwise we will check this condition also and we will go for iteration. Now for if we are not getting if we are not reaching the last index, then after this loop we will simply return false here. So what we are doing here, we are starting from the 0th index and then we are checking each and every condition, right, using this j loop, so that we don't miss out any index and any possibility. And let's say we reach the condition where I is equals to length of n minus 1, means length of the array minus 1, then we will be returning true. And if at any condition I am finding that nums is equals to 0, nums of I is equals to 0, then I will simply return false there. Okay, now this is our recursion code. How do we memorize it? The entire code will remain same. Only after this if condition, what we will do for memoization, we first of all we will declare an array, right, which is, we will declare a dp of size n, with -1, right. Now what we will check, if dp of I is not equals to -1, then we will return dp of I, right. Now this is our condition that we will be inserting here. Again in our for loop, what will happen, where we will returning true, right. For I j is equals to I plus 1, will go till I plus nums of I and we will be going till less than equals to nums of I, and we will check condition if j is less than n. And we will be looping also, right. So whatever function name we are taking, we will pass j in that with our array. And what we will be doing here, we will be storing our value. Here in the previous one, what we were doing, we were directly returning the value, but here what we are doing, we will be storing the value in our dp. Okay, now why are we doing this? We are doing this because in recursion, what we were doing, we were checking the conditions again and again. Means if I have iterated for 3 and I know that it will be iterating 3 times, right. So this in recursion, what is happening, it will be checked again and again, but dp what it will do, it will store the value, and we can simply use that value to means solve the problem in the further, okay. But and in this way, what will happen, like whatever iteration we were doing, it will not be repeated, and we can simply use the stored value in our answer, okay. So like we were returning directly true there, what we will do, we will store that in our dp, right. And if after this I will be returning my dp of I, and here also first I will store in my dp false value, and then I will be returning dp of I. You can directly write, if you are using Java or Python, sorry, Java or C++, then you can directly write return dp of I is equals to false, but in Python it will show an error, so you need to write this in separate lines, okay. So this is what you have to do here, okay. Now we had a means in the recursion, what we had, we were using time complexity of O of n square, right. Sorry, it was O of n power n. So in recursion, we were using a time complexity of O of n power n, because for every every index, we will be again starting a recursion function, right. We will be again calling the function, and everything will be repeated again. So we were taking a stack space also, because of that we were having a space complexity of O of n, right. Now this O of n power n, that exponential time complexity that we had, was reduced in our dp, right. But we also introduced one extra space here. We are using recursion here, but with that, if we are using recursion also, so for that stack space is there, and also we are declaring a dp, so we are taking two O of n spaces, right. Now we need to reduce that, right. Now what will happen, we will move on to tabulation. So tabulation is the reverse order of recursion, we can say, because recursion is a top down process, and in tabulation we start from bottom, but it is a bottom up process, okay. So what we were doing in recursion, we were moving from I is equals to 0 to I less than equals to n, right? Now in tabulation we will reverse this. Okay, so now what will happen, we will be starting the iteration from I is equals to n minus 1. Now before that we need to take care of some edge cases, right, that we were having here. So we had one base condition that if I was equals to n minus 1, then I had to return true. And before that we will be declaring a dp here. So what I will do here, I will declare a dp of size n and all the values will be initialized by false. Okay, now for the dp value at n minus 1, what I will do, I will declare it with true, right? Because when we know that we are reaching the length n minus 1, then we have to return true there, right? Now since we have this n minus 1 value, so we will start the iteration from n minus 2, and till where we will go, we will go till I is greater than equals to 0, right? And we will do I minus minus because this is reverse order. Now in the approach that we used here, what we were doing, we were starting from I plus 1 till I plus nums of I, right? We will be doing the same here. So our inner loop will be starting from j will be starting from I plus 1 and it will go till I plus nums of I. Okay, now what we will do, we will check a condition. Okay, if like we were doing in the previous one, if j is less than n, right, and dp of I is equals to true. Okay, or simply we can write if j is less than n and dp of n, which means that it is also true, then what we need to do, we need to store dp of I as true. Otherwise, out of the loop, out of this condition, right, what we have to do, we will be storing the value as false, right? Now what is happening, we have already declared our dp initially with false, right? So we do not have to change the value to false. We are only checking the condition, we are getting our true value, means we are reaching the last index, and we are simply flipping that value to true. So we don't have to check for false conditions here, as initially we have initialized the entire dp with false only. Okay, so we will only change the value of dp to true and we will complete out of this loop. What we will do, since we are iterating backwards, so the final answer of our or the final value, it will be stored at 0th index of dp, right? So what we will do, we will return dp of 0. Now here what we are doing, we have removed that stack space and we have reduced the exponential time complexity to a time complexity of O of n square, right? And here we have space complexity of O of n, right? Now we will be running this code also, but in like on the code editor in Leetcode, we will be facing time limit exceeded. Okay, so we will be seeing a one more optimized approach where we will be having, it will be optimized approach where the time complexity will be of O of n and space complexity will be O of 1. So now let's take an example. Okay, so let's say we have an array nums, like in the previous example we had used 2 3 3 1 4. Now I can only reach the last index if I have enough values to reach the last index, right? Now let's say I am storing the maximum, all of the maximum elements that are provided to us, or the maximum jumps that we can reach, and we will have to check, means if I am on the first index, right, zeroth index. So what will be my maximum value? Whatever value we will have, we will get from I plus nums of I, right? Because if I am at zeroth index, then I can start the jump from that index. After that we can take two steps, right, or two jumps. And if we are on first index, then we can jump three steps after one, right? So we will after one we will take we can take three jumps, so we need to add here one, right? Now what will happen? Now let's say we have max value, okay, max jump. In this, what I am doing, I am storing the maximum of the previous max jump and the one that I have got now, right? I plus nums of I. Now I am on the zeroth index, fine. My max value will get updated to 0 plus 2, that is 2. Initially we are initializing the max with 0. So now what it will happen, we will compare 0 comma 2 and we will get 2 as our max max jump right now. Now after that what will happen? We will go to this index, right, and we will take 1 plus 3, that is 4, and we will compare 2 and 4, we will get 4, right? Now we are on zeroth index, then we have first, second, third, fourth. We can reach fourth index when we have that many maximum jumps available, right? Means let's say I am on first index and I get my value as 3. So I can go to the fourth index, right? Because I have that maximum number of jumps that I can reach the last index. But let's say I have a condition like 2 1 0 3, okay. Now I am on this index, okay. So I will take one, I can take two iteration from here, and from here also I can take only one iteration. Now on in any circumstances when we are facing 0, what will happen? This will become 0 and after this we cannot move any more forward. Now we are on 0th, we have 0 1 2 3, okay. Now we can only reach the last index if we have 3 as our maximum value, right? Or any number of jumps signifies that we can jump for 3 indexes, right? Now if I try to take the maximum value, so for the first step we will get 0 comma 2, so I will get 2. After that, on the first index, what I will do? It will become 1 plus 1 2. That means after 1 I can only step 1 index, right? So max will compare 2 comma 2. We will get 2 only. Now when I reach on the second index, still it is 2 comma 2 because it is 0 and we have 2 here. So it will become 2 only. Now let's say I am iterating, okay, on the array and I come on the last index. My last index is 3 and the maximum number of jumps that I can do is 2 only. Then how will I reach there? It is not possible for me to reach the last index, right, after from the first index, because my max number of jumps, max jump is equals to 3 only, right? Is equals to 2 only. So I cannot reach the last index. So in condition where the maximum number of jumps become less than the index that we are on, right? Means we are on the third index here and my maximum jump is 2 only. So I cannot reach the last index, right? That is the third index. So in condition where we are saying if max jump will become less than the number of the index that we are on, if we are not having maximum number of jumps available, then we can directly return false, right? Because we can, if we have reached such an index that the index value, maximum jump value is becoming less than the index value, then we cannot reach that index only. So we can simply like return false, and every time we need to means update our max jump also, and for that what we will do, we will write max jump is equals to max of max jump and I plus nums of I. Now this what we are doing, we will be means these steps will be taking inside in a loop, right? Because we are iterating from the first index of the array to the n minus 1, right? Now let's say I have iterated in the entire array and there is not even one condition where I see that the max jump becomes less than I. So out of the loop, that what I can simply do is I can simply return true, right? Because there is not even one condition that we are finding as false, and our entire means we are able to reach from the 0th index to the n minus 1th index. So I can simply return true out of the loop. Okay, so now let's move on to the code. And before moving on to the code, in case if you are having like any doubts regarding the approach that we have followed, please let me know in the comments, so I will try to clarify it. And I hope that you were able to get what I have explained here. So now let's move on to the code editor. So let's move on to the code. Right now I will only be doing the optimized code, and the recursive and dynamic approach I will be uploading on my GitHub. You can access those codes from there. So what we were doing, first we will declare a value to store the maximum jumps, right? So I will declare maxi and I will be initializing it with 0. Now we will start the iteration from 0th index to the length n minus 1th index, right? Now we have started the iteration. Now let's say if I reach any index where like the maximum jumps become less than that index, so I will simply return false there, because if my max value is less than I, then I cannot reach that index only, right? So we will return false there. Otherwise we can simply calculate our max, and if we do not come across any condition where we are returning false, so out of the loop we will return true, because we have finally reached our last index. Now let's try to run it. So the sample test cases are passed. Let's try to submit it. So this code has been accepted. That's it for today, guys. Thank you for watching. If you found this video helpful, please let me know in the comments. And in case you have doubts regarding any of the approaches or any of the previous questions, please let me know in the comments. I will try to solve it as soon as possible. And if you want to continue with me in this coding journey, please subscribe to my channel and hit the bell notification so you will be notified every time I post a new video. Thank you for watching.